Hi everyone, so earlier this week I made some videos talking about some predictions I'm making to the stock market and the gold and silver market and even the forex market, and also some interpretations of what it means for the oil price to go negative based on astrology. So I thought I'd do a little, uh, make it a little bit easier to understand by putting it down to scale where you and I can actually go out to take a look at this. So if you live near Washington, take a drive on I-90, and I think it's near exit 143. You have this scenic overlook, and you can drive in there. It's open 24 hours, and personally, I have a funny nickname for that. I used to call it Ellensburg Space Station, but now that I've gone there to see the Milky Way, and sometimes it's a stopping point for when I go out to the Rocky Mountains, I sometimes call it the Hotel Milky Way. You know, it's like a Milky Way. It's like a hotel room right under the Milky Way. You know, and I can stay there overnight and watch as the Milky Way appears overhead, and then some of the planets. It's like an observatory to me. And what I really like about it is that it's kind of like a trip to space because it's 143 miles away. You kind of leave Seattle behind, and very nice. So you can think of it as a scenic hotel, or you can think of it as a space station. Either way is fine. Depending on what I'm doing, I've given it different nicknames. Okay, so my favorite viewing is to watch the moon or the sun disappear behind the horizon, and especially the full moon in either July or August usually disappears at just the right angle for you to see from the scenic overlook. Unfortunately, I haven't been there recently because of all the craziness that's going on. I'm not sure if they have closed the rest stop because of COVID-19. But obviously there are other concerns too. Okay, so usually you're laying back here watching the sky, right? And you have Jupiter and Saturn, and then the ecliptic. If you have the right app, it will show you where it is. And there's usually a small angle between where the planets are and where the ecliptic is, right? And obviously, there are star constellations behind the solar system, right? And these stars are way out there, right? Jupiter is about an hour to 2 hours in terms of light distance, and these stars are at least multiple light years away, right? So you get the idea, right? Think about what you can do in an hour or 2 hours, right? And think about what has happened in 4 years, right? That's a good idea of the ratio, right? Anyway, some of the parameters we can measure is how far the planets are, right? They do change because the Earth orbits the Sun at about 93 million miles. We call that an astronomical unit. Jupiter orbits at about 5 astronomical units. Saturn is about 10 astronomical units. And so we can call that, for Jupiter, let's call it R. Jupiter is probably a much bigger influencer to human psychology than Saturn because it's both closer and about 2.5 times more massive than Saturn, right? And the angle that it's separating from the ecliptic, right, rho, and also the angle at which the constellation it's at, right? That's we can call that theta, right? The angle between Jupiter and just pick any constellation, right? I believe usually it's Eris that is picked for the reference, right? Okay, so for each planet we have three of these variables, and the idea is that the market index, right, whether you're measuring the price of gold or Dow, the index, at the end of the day, you're going to model that as a function of these guys, right? Rho, R, rho, and theta. Well, is it a linear function? Is it a... Well, if you think about it, the radius can go from, what is it, 4 to 6 astronomical units, right? So if we were charting this out, there's going to be a trend, right? When it's 4 units, when it's 5 units, when it's 6 units, it might be up and down, right? Now, how are we going to fit to that? there are multiple math functions that come to mind, right? It could be a linear fit, but it's probably going to be a polynomial fit of multiple degrees, right? So you're going to have something that looks like uh, the constant coefficient times some linear times a square times a cube. And you have to decide how many coefficients you want to use, right? The more historical data you have, the more coefficients you can have without overfitting, right? Now, the most interesting one is the theta, right? If you were plotting out as Jupiter zoomed through the sky, right, between 0 and 2 pi, right? 2 pi radians, right, for the entire circle of the constellations, right? You would probably have some kind of a wave to it, right? How we're going to fit that. The best way is probably the Fourier series, right? Where you're modeling this as a combination of sine and cosine waves, right? Um, so, for example, if you modeled it as a sine of theta or cosine of theta, it's going to have a period of the whole 2 pi, right? If you remember from trigonometry, sine and cosine has a period of 2 pi, but there's also shorter cycles in there, right? The stock market tends to go up and down a lot more than once a year, right? So you're going to have terms that look like sine of 2 theta or cosine of 2 theta. They have a period of pi, right? Now for your rho is usually a much smaller. It doesn't stretch the whole 0 to 2 pi, right? Obviously Jupiter stays very close to the ecliptic. That's why we have a full moon every month, right? The moon doesn't diverge so far that you have a whole month where you only have quarter phases, right? It's possible to do that if it were perpendicular to the sun, but that's not how the solar system formed, right? Even if it formed like that, in the long term it would have converged to being flattened out, right? Eventually, we'll probably have an eclipse every month, right? Except the moon will move so far away from the Earth, it won't be a full eclipse anymore, right? That's the stable state for the moon, right? So what are you going to do about this guy? Well, this guy only varies from 0 to probably, in terms of degrees, probably 5 to 10 degrees, right? So we're probably going to do something more along the lines of polynomial fitting. So depending on how many terms you want to use, right, for each of these variables, you could have anywhere from 20 to 30 coefficients to tune, right? The more coefficients you have, the more data points you probably will want to have, because if you have obviously if you have more coefficients and data points, you just have noise, right? Even if you don't have more coefficients and data points, if you have too many, you have overfitting, and your model basically learns the data too well and doesn't extrapolate away from it, right? So that's a fine tuning that you have to do, right? For me, I only use linear for the radius. Actually, I'm gonna have to play with that a little bit. I use 12 terms for the Fourier series because there's 12 signs of the zodiac, and that's what most people mess around with. And I only use linear for the divergence from the ecliptic, but I'll let you play around with it. Let me know if you know any other good vantage points for viewing the night sky. I know for the ecliptic, Ellensburg works really well. If I want to view things that are off to the north, like the Northern Lights or something, what comes to mind is Gdansk Bay. Obviously, I don't go there nearly as often as I go to Ellensburg. Anything close to the equator would be good if you want to see things directly overhead, right? Without too much. The closer you can get to being directly overhead, the less atmosphere you have in between you and what you're looking at, right? Usually, if I want to look at the moons of Jupiter, I haven't really investigated this yet, but I wonder. Obviously, Jupiter has 4 big moons, and they have periods that are only a few days, if I remember correctly. Io, Europa, Ganymede, Callisto. They have periods that are. I think Io has a period of 1.75 days, and then they double roughly as you. There's a resonance of 1, 2 to 4. I wonder if I could plot that out. I haven't had any luck programming the astronomical algorithms for them. I tried programming them one time, and the numbers didn't turn out right. I must have a mistake somewhere. Saturn has 1 big moon, Titan. That's probably a little bit easier to program because it doesn't resonate. It's almost independent of all the other moons of Saturn being so much more massive. What else could I add into? I also didn't factor in the effects of the moons of Mars. They are tiny, right? They almost have no gravity to them. You could jump and escape one of those moons, right? That's how tiny the moons of Mars are, right? What else could I have programmed? The solar system itself is also moving, right? It orbits the center of the Milky Way once every 250 million years, right? We don't have enough data to model that, obviously, right? There are some theories that every time the solar system goes into a certain region, there's a massive extinction event, right? Life has been on Earth for about 3 billion years, so about 12 of those revolutions, there's an extinction event, and apparently we're headed into one of those. So there's a theory about that. Anyways, so this is how I this is what I used to show the last few predictions.